Okay, yeah, I think I'm live now. Can anyone confirm if audio, video, everything looks fine? And probably let's spend a couple of minutes before more folks join in, and then we will get started. Any questions for me until then? Okay. Hello, hello, hello. Thought you will return next year for Blitz Cup. Yeah, I think that's correct. I will definitely return next year for Blitz. But yeah, I think it was a long weekend, so I am here. So yeah, I was able to solve first five problems. So I will discuss the first five problems. I think I had some ideas for the F, but the implementation was quite tedious. No, I did not skip B. Like its system testing is going on, so it's removing the submission and coming up. Long time no see. Yeah. What's my take on current Coach F contest? Is it worth giving irrespective of cheaters? Let's split it into two parts. Is the contest worth giving for without irrespective of cheaters? I think you should always do it because that's how you are going to improve yourself. And what's my take on Coach of contest? Frankly, I haven't seen any problem from Coach of for last 1 year or so. So I don't know what's the current state. But yeah, I think this is all will have to say. I have to say about it. Couldn't prove D. Okay, I think D was quite a bit of casework. That's what I can say. And E was kind of greedy and something, let's say, proof by AC, something how I tried to solve it. My favorite problem in the set was C. And by the people in the chat, like how many problems were you able to solve today? And like where were you stuck? Like this will give me some fair share of idea, like where the most people are. No, it's definitely not okay to use AI for code. Like just because you know the problem but doesn't know how to solve doesn't mean you should be using AI for code forces and all. Like basically different things have different purposes. If you are probably doing software engineering, then that's fine. But here all you have to so is like how you are able to solve problems fast, and AI just defeats the purpose. You solved E very quickly. I think I did try to prove something, and like like let's just say like a trivial string problem. Like the problem is kind of a bit trivial if you know a few things, and if you just try to go for proof by easy. So yeah, beginner did only B. Only solved two. Third was getting yeah n plus two. I think I also spent quite a lot of time on C, where I had n plus two solution, and like n plus one was a bit hard, and that's what makes it an interesting problem to be honest. So yeah, I think I will discuss all the problems going from A to E. I will skip F for today. Any more questions for a couple of minutes before we jump onto the problems now? Is thinking about DP for D valid? Actually, my solution does not involve DP in D, but rather a lot of casework. So I think let's get started. Otajet set up a battle with N monsters in order to increase its combat power. Each monster has a combat power AI and Otter has a combat power C. He has K flip bits and can perform the following operation. Kill an alive monster if AI is less than equal to C, then C becomes C plus AI. Throw a flip off at the monster eye, the flip flop will be broken and the monster will become angry, and then AI becomes AI plus one. Help Otter Judd obtain the maximum CA after the battle. So, like, problem statement simply says, like, you have an array of elements. Hmm. A1, A2 up to AN. In one go, you can choose an integer. You can choose an index, let's say AI. If AI is less than equal to C, then you can remove it from here. Then you can remove AI from here and change C equal to C plus AI. Like this condition is a bit more important here. This is one type of operation. You can choose any AI whichever you want. Or you can change AI equal to AI plus 1. But this can be done only up to k times. And like that's where we are. And overall, like the idea is like since it's problem A, so I will probably not go into a lot of proof here. But overall, the idea was every time when you have to choose the smallest element, increase it as much as you can, and then do an operation to add it into C. So the idea is choose smallest element. Choose smallest, increase it, keep increasing it as long as it's less than equal to C. Okay. Basically do plus 1 plus 1 plus 1 as long as it's less than equal to C, and then do an operation C where you basically increase your health by that value. Overall, I think this is the overall idea here. And the way you do is like instead of finding minimum every time, you can sort the elements so you know which elements you have right now, and every time you keep increasing the elements and then keep going. So I think this was the solution for this problem. You first take n ck as input, take all elements as input, sort the elements in an increasing order. Like this is the problem so far. Like how many times can you increase over here? Like if current element is greater than C, then you cannot do anything. Otherwise, you can keep increasing it for some time. Number of times you can increase is either the value of k, number of maximum operations you can do, or because you want to take the current element, so you can only increase it up to C. So the how much smaller the current value is compared to C is what you can increase. Now you will use these many operations to increase the value, and the number of possible remaining operation also decreases by the same value. And then you increase C by current value of X. Or instead of X, let's just call it AI. So this was the solution over here. Any questions anyone on the problem A before we jump on to the next problem? Yes, I do use Arch, but I am planning to shift to Mac. So like the moment it arrives, I will probably switch to Mac. Okay, I cannot submit it right now. System testing is going on, but yeah. Overall, I think this was the idea for the problem. Any questions on problem A before we jump on to the next problem? Okay, I think then couple of minutes for questions and then I will jump on to the next problem. Look, how to increase rating? You can join the Discord server. The link is in the chat. There, I have a channel roadmap to read. You can read all the tips and tricks I have to share in the channel. And probably for more questions, you can stay until the end. At the end of the stream, I usually answer these questions. So the problem is you are given an array of length n. For each index I, find the maximum number of index j such that j is greater than I and difference of ai minus k is greater than aj minus k or all possible integer values of k. And like n is up to 5000, so we don't have to do a lot of stuff here. So we can probably go for something n square as well. So probably let's first see what are the optimal values of k. So if I have to briefly explain the problem statement, like first it says j greater than I. So essentially we have to only look at the suffix. Let's try to first solve for a1 and then the idea would be similar for everything else. Let's try to solve for a1. Then we have to find a1 minus k. We have to choose some value of k and then we have to find number of index where ai minus k is greater than aj minus k and number of such j and we have to print that count. So essentially the idea is what we have to do is we have to choose some k such that count of these integers is maximum. So yeah, I think problem is a bit confusing here, but overall this is what it's asking. We have to choose some k and such that the number of elements j where this equation is satisfied is maximum possible, and we have to print that maximum count value. So yeah, I think overall this is the first problem. Now let's try to any questions on the problem statement so far before I jump on how to solve this. So yeah, like the idea is one thing that helps a bit was like let's, because this A1 and AJ confuses a lot. So let's just try to make it something simple. Because we can choose any value of t, okay? Let's choose instead of t some t. We will choose some value of t, some value t, and then we will set k equal to minus t minus a1. Okay, can you please explain the line over all possible values of k? Yeah, actually, like this is the most critical value. The idea is we have this equation. We can choose some k over here. Let's say we choose k equal to minus 2. We get some count of integers where this equation is satisfied. Let's say such count is 3. Let's say we choose k equal to 0. We get number of such indexes as 2. Let's say we choose k equal to 10. We get count of such indexes as 5. Let's say we choose k equal to 15. And let's say we get the count of such integers as 6. Then the idea is take maximum value of these and print it. So in this case, we will print 6. And we can choose any other values as well. So this was the idea. Okay? You check this equation value for every value of k and then print the value where you get the maximum. Basically, so overall the idea is like you try to put k as every value like minus 10, minus 2, minus 5, minus 6, 0, 4, 3, 10, 12, everything. And then see how what are the number of indexes where this equation is satisfied for every such value of k. And then print the maximum value of indexes you get over here. So that's the idea of like for every value of k. So because we are anyways choosing any value of k, let's say I will choose t and I will select k which would give me as this equation, which will be minus t minus a1. Why I am doing this? Because I am trying to simplify my old equation. My equation is this is my equation, right? Now let's just replace this equation with t here. Let's keep this plus. Let's say I will choose k is equal to some t minus a1. Now if I put this equation over here, I will get minus t. Let's just put it minus t plus a1. So I will get is t minus a1 greater than aj plus t minus a1. Looks fine, right? If I am going to choose t and I will going to set my k is equal to minus t plus a1, something like that. Now what you can see is like now here a1 cancels out and the equation becomes mod of t greater than aj minus a1 plus t. This is my equation. Let's just try to also put this some variable as let's say dj, because like this is the fixed difference from aj. So my equation becomes like what I am defining is like instead of using original array a, I will create a new array dj, which would be equal to aj minus a1. Then my equation essentially becomes mod of t greater than dj plus t. Now, if we have this equation, like, can you see, like, now it's simple to find, like, basically what the values are here, right? Or, like, any ideas now before I jump on to how to probably solve it a bit further? So now the idea is, if dj is positive, let's say this is some positive number, then if t is also positive, then this equation will never hold. Then, like, this equation will never be satisfied. If my dj is positive and if t is also positive, then doesn't really matter what the value of dj and what the value of t is. This will never hold. But if dj is positive and t is very, very large, let's say minus 10 to the power 9, or let's say 10 to the power 20, then this will be equal to 10 to the power 20 negative of same value as 10 to the power positive. This would be 10 to the power positive, and like this would be something else. Basically, if my equation will become, because it's a mod, you can actually flip the signs over here as well. This will become 10 to the power 20, and because dj is up to 10 to the power 9 or something, this will become 10 to the power 20 minus dj, and this will always hold. Like, this will always be true. So what we say is, like, if I choose 10 to the power minus 10 to the power 20 as k, then all the values which are where we have dj greater than 0, the equation would be satisfied. So essentially the takeaway here is, if my t is minus 10 to the power 20, then I can essentially take all dj greater than 0, and the equation would be satisfied. T minus 10 to the power 20, I think you can probably try to put where the k is. And if you put dj equal to aj minus ai, which is greater than 0, which says aj greater than ai. So essentially, all I can do is, if I am choosing t as minus 10 to the power 20, I can choose all aj which are greater than ai, and like for this, the equation would be satisfied. You can similarly try to put t equal to 10 to the power 20. Here, that equation would turn out to be dj greater than 0, and overall, like, this would again be aj less than ai. So what you have to do is, for a fixed number, you count how many values are less than it, how many values are more than it, and just take the maximum of these two indexes, and that would be your answer. So I think this was the overall idea for this problem. First, take all the numbers as input. Now fix an here. Now go for all possible j which are greater than I, j equal to I plus 1 up to n. If aj is less than ai, you take p a positive difference. And if positive values and negative values. And then you just print any question so far. So yeah, I think this was the problem. Like any question so far on problem B before we jump on to problem C? Yeah, I think solving it in n plus 2 operations is easy, but n plus 3 operations is quite hard. Sorry, n plus 1 operations is hard. Okay, what is the stuff called equal slash and n plus 1? So the idea is I am printing an array. I want to print spaces after first n minus 1 indexes and a slash and basically new line after the last index. Because most of the time people use it. Like another way to, more often than not, I think this is how people print answer. This also works fine, but my problem is like I am using like some string comparator only, and this extra space at times causes calls out differences here because the file I have downloaded from Codeforces is does not have a space after it, but when I'm printing it, it has a space after it. So whatever comparator I'm saying, it says there is a difference everywhere. So to circumvent this, what I people simply print is this. If because the index is from 0 to n minus 1, if I is equal to n minus 1, then this equation holds. So it prints second character, first index character from this string, and if the equation is not true, it prints 0 index character from this string. So this string has two characters, character 1 and character 2. So if it's the last character, it prints new line. If it's not the last number in the line, it prints space. So that's the whole idea over people using space lesson. Yeah, I think I will also share the approach for n plus 2 as well and see. Any questions so far before we jump on to the problem C? Okay, let's move to problem C. It says find the zero. This is an interactive problem. You are given an integer n. There is an hidden array a of length 2n. Each integer from 1 to n appears exactly once in an A. The rest of the elements are 0. So it says, for example, if n is equal to 5, then you have 10 elements. 5 of them are 0, and remaining 5 are 1, 2, 3, 4, 5. We can make the query of following type. We will give judge two elements, and judge will say if they are equal or not. That's the only information we will get. And now we have to find an element which has 0 value in it. And like it says the judge is a bit adaptive. So like I think we will come on to the adaptive later on, but overall, let's just say we have to find it deterministically. We cannot use some random stuff. And we can use at max n plus 1 queries. So let's say we have n equal to 5. Now we have 10 elements. Now these are the 10 elements. What we can do, ask to judges, we can choose some index, let's say this and this. And judge will say if elements at both of these are same or not. We can ask at max 6 queries. And we have to find any one element where 0 exists. In this case, we can print any of this, this. Any questions on the problem statement so far, like what the problem is asking before I jump onto the solution? Okay, so like in problems like this, it's always better if you solve for a smallest case first and then try to generalize it. Like for example, what happens if we have n equal to 1? We will either have 0 or 1 or 1 or 0. Like these are the only two possible arrays. And you can never figure out which of them is 0 because you can only ask I equal to 1 and j equal to 2 as a query, and the answer will always be they are not equal. And that this is also the reason why problem says n is at least 2. So if we can solve for n equal to 2 in 3 queries, like this is if we can solve for this problem, then we would be able to possibly generalize it, because this is the smallest case. We have to anyways figure out a solution for it. In this case, we will have two zeros, we will have one, we will have two. These are the four elements we will have. And like let's say if we ask a random query in this array, is ai equal to aj? When will this be true? When both ai is 0 and both aj is 0. Nothing more than that, right? Because one is there only once, two is there only once, and so on. So like if you choose that as an element, then whatever the other element is, you will always get that these elements are not equal. So now first let's try to solve this in four queries, then we will try to solve it in three queries. The idea is a lot different, but a lot of people solved it in four queries. Let's say we ask, is a1 equal to a2, and is a3 equal to a4? If any of them is equal, then you can just print that element. For example, if you get true here, then you know that 1 and 2 are the zeros, so you can print 1 or 2 and move on. Or if 3 and 4 are equal, then you will get 0, and then you can both of them would be 0 and you are good. So if you get true in any of these queries, then it's fine. Otherwise, like a1 will not be equal to a2 and a3 will not be equal to a4. So like the possible array for you, like without loss of generality, we can say like the array looks like this. Either this, like I am not differentiating between 1 and 2, like we care less about where they are. Like you have used two queries and both of them were false, so you didn't gotten any answer so far. Then now this is how your a1, a2, a3, a4 will look like. Like technically 2 can be here too, but I care less about, like, all I care is the element 0 or not. Now the next thing you can do is, like, now you can ask, is a1 equal to a3? If this gives true, then you can print any of this index. And if this gives false, if a1 equal to a3 gives you true, then you can print 1 or 3, whatever you want, and you are done. Otherwise, this case goes away. And you still have these cases remaining. So now I have used 3 queries and I still have these 3 cases here. What all 3 queries I have used? A1 equal to A2, A3 equal to A4, and A1 equal to A3. Here I have asked, is this element equal to this one? If this doesn't work, then you simply ask, is A1 equal to A4? If you get a true here, then you can print A1 or A4, and this is your case. And if you get false here as well, then you can just print A2. So this is how you will solve for n equal to 2 in 4 queries, which is n plus 2 queries. Any questions on this solution so far? The idea is check A1 equal to A2, A1 equal to 3, A1 equal to A4, and A3 equal to A4. So, like, a bit of casework, but this is the idea here. Or another way to look at it is like this. You compare A1 with A2. You compare A1 with A3. You compare A1 with A4. If any of them is true, then you can just print A1, because, like, this will be true only for 0. So otherwise, you know that your array is like this. And if all of these 3 were false, then this is either 1 or 2, because it cannot be 0. Let's just, for the sake of it, let's say this is 2. So now here you know that 2 elements are 0 and one of them is 1. We have 0, 0, 1 in some form over here. In some form over here. What you can do is, now you can check any pair here. Let's say we check A2 equal to A4. If we get true, then you know that A2 and A4 are 0 and you can print it. If we get false, then you know that either this is 1 or this is 1. One of them is 1 and another one is 0. But it doesn't really matter which of them is 1. You always know that A3 will always be 0. Because the moment you got A2 is not equal to A4, then you know that 1 is either on 2 or on 4. So because you have first figured out that A1 cannot be 0, you figured out that another non-zero element is on 2 and 4, then you know that for sure 0 exists on 3. So you can directly print 0. So this is how you can solve, one more way to solve it in 4 queries. So I have said 2 ideas on how you can solve it in n plus 2 queries. And I think I'm pretty sure people would have figured out even more ideas to solve in n plus 2 queries. Any questions so far? Like, now the question is, like, let's say n is equal to 100, what can you do? My idea is, like, we can use the same idea to solve it in n plus 2 queries. The idea is, like, let's say elements you have is A1, A2, A3, A4, A5, A6, A7. Keep going. So the what I would do is I would first check A5, A6. If I get true, then I am good. Otherwise, I will simply remove these two numbers. And what I know is like at least one non-zero will go away. Then I will look at 7 and 8. If this returns true, then I can print this index because this is 0. Otherwise, I can remove both of these. And at least one more 0 will go and so on. You can try to do it for all the pairs up to 800. And if you don't find any success there, then you would be left with 4 pairs again, and you will use n minus 2 queries for removing all the pairs so far. And after that, you can solve within 4 queries from A1 to AN to get overall 4 queries. 4 queries for this and one query to remove each of the pairs. So, any question so far on how to solve it in n plus 2 queries for any value of n? So now let's try to solve it in n plus 3 query, n plus 1 queries. Solving it in n plus 1 query means we have to solve for 4 n equal to 2 in 3 queries. I think wait, if we remove those pairwise and we put last one pair and ask query, we can do it in n plus 1. I think I was trying to think along those lines, but then I realized I will have to solve anyways for n equal to 2. So I did not try to figure out the nitty gritties of how to solve it in n plus 1 for the larger n. So where, okay, can you guide me where and how to learn segmentary? I think you can look at USACO guide for segmentary. And there is actually a good blog on Codeforces as well. I can share the link at the last when we are done with discussing all the problems. So, like now, let's try to solve for 4 elements using 3 queries. Now we have 4 elements and we have to solve within 3 queries. Any ideas over here? Like this actually requires thinking it in a non-trivial way. Like I was trying to play around multiple different ideas, then I got to know over there. Like let's first forget that my idea is let's first forget A4 even exists. Let's check if A1 is equal to A3. If we get a true, then we know that 0 is in 1 and 3 and we can print it. Otherwise, let's check A1 and A2. If it returns true, then we know that 0 exists in 1 and 2 and we can print it. Otherwise, let's look at A2 and A3. If it also returns 0, then I know that 0 exists on 2 and 3, we are good. If all of these are false, then what can you say here? You can say that one of them must be 0. Basically 0, 1 and 2 should exist over here. Otherwise you could have got some pair equal, right? And essentially this idea again, that 0 1 exists here, 0 1 exists here. And because you have figured out 0 1 and 2. Okay, can I explain again? So the idea was, let's look at all pair of elements a1 and a3, a1 and a2. Let's first forget a4 even exists. Let's try to figure out a pair between a1, a2 and a3. So we check a1 and a3, we check a1 and a2, and we also check a2 and a3. I have checked all of these pairs. If any of them says that pair is equal, then I know that those two elements are zeros and I can print that. Otherwise, if what I have got is a1 is not equal to a2, a1 is not equal to a3, and a2 is not equal to a3. In that case, because we know that our elements are 0, 1, and 2, then 0 must exist somewhere in these three, 1 must exist somewhere between these three, and 2 must exist somewhere between these three. Because only if you have one of them element as 0, one of them element as 1, and one of them as element 2, then only you can get no for all the three checks. And because you know ki 1 and 2 exist, yeah, so if 1 and 2 exist between one of these three indexes, then this value must be 0. And that's the idea over here. Yeah, I think this, like now you will realize this is simple, but I think this is the beauty of this problem. The whole reason why I like this problem. So, like, this is the main idea over here. And once you can solve for n equal to 2 in 3 queries, then you can solve it for any big n as well. Like, the idea is you look at 5, like you look at a, like again the same concept idea, like you check first 5 and 6. If they are not equal, you remove them. You look at 7 8. If they are not equal, you remove them. You look at 9 and 10. If they are not equal, remove it, and do it up to 2n. You will end up using n minus 2 queries, and you will just have a1 a2 a3 a4 remaining with you. You can use n minus 2 queries to reduce this to problem of 4 elements. And then you use 3 queries to figure out the remaining among them. So overall the answer is n. You will get in n plus 1 queries. Any questions so far? And yeah, I think this did took me even quite a significant amount of time. So like once you realize the problem is simple, but actually I found it to be the hardest problem among all the 5 problems that I have solved in the problem. Actually, if I go by time, it's around 23 minutes on this and 27 on this. So D technically took more time, but I think D was more when it came to coding, but at least trying to solve it like the hardest was the problem solving. Oh, so that, okay, what I'm saying is, let's say we have 10 elements. Then you can first we can first check A9 and A10. If they are equal, then you can directly print it. Otherwise, you can look at A7, and A8. If they are equal, print it. Otherwise, look at A5 and A6. If they are equal, then print it. If not, then try to solve for A1 to A2, A3, A4 in three queries. So overall, you will end up using three queries here and three queries. They're total six queries. And because you have any total 10 elements, six queries is fine. So overall, the idea is you try to look at a random pair. If they are equal, print it. Otherwise, now you can forget that those elements exist. And you have used one query. This way, you can remove all the elements and just keep four elements at last. And removing n minus 2 pairs will take you n minus 2 queries. And then you can solve for those four elements using three elements, and overall the answer is n minus 1. So if I have to jump onto the code, okay, let me just first submit A and B code. Okay, so the idea is I keep the first four element 0, 1, 2, 3. Then I simply go from 4 up to 2n, increment by plus 2 every time. And if I ask I and I plus 1 are equal, if I get that, I simply return it. Otherwise, once I am done here, so now I look at if 0 and 1 are equal, then print 0. If 0 and 2 are equal, print 0. If 1 and 2 are equal, print 1. Otherwise, you know that 3 must be 0 printed. So overall, this was the solution for this problem. And print is like printing a query, and ask is like ask query. Any questions on problem C? And yes, I think Teja Smart did message me for a blitz challenge, and I don't know what the current plans are, but yeah. And it was like, yeah, we will do a blitz contest, and then we have materialized the plans. So, any questions on the first three problems before we jump onto the fourth problem? So, this was problem C for today. So, problem D, I think it was a greedy problem. Any questions so far before we jump on to problem D? Okay, let's move to problem D. Otajat decided to take a weapon using Ghostfires. He collected several Ghostfires in colors red, green, and blue. He will put some of the Ghostfires in a row to build the weapon. To make the weapon more powerful, Otajat will use as many Ghostfires as possible. But the weapon will be out of control if there are two Ghostfires of same color adjacent or separated by exactly two Ghostfires in a row. Formally, Otajat has collected R red Ghostfires, G green Ghostfires, blue Ghostfires, and he wants to construct a string as consists of characters R, G, B that satisfies the following conditions. The number of occurrences of R, G, and B does not exist more than R, G, and B respectively, and no two nearby elements are equal, and no elements with difference 3 are also equal. And we have to find the maximum length of S as big as possible. Some samples are given, and like samples don't help a lot in solving the problem, but this is where we are. Any questions on this problem statement so far? Okay, I think it's a bit of greedy problem where you try to maximize the length. Maximizing length is trying to put as many element as you can. And I think the way I solved this problem was looking over different patterns. And I think what I will end up doing is just repeating some of the patterns I have. Let's just say like the colors are given in the form such that blue would be less than equal to green, green would be less than equal to R. Let's just assume that this is the case. We can try to tries all the other cases into something like this. So I will simply assume that number of blue we have to put is less than number of green, and number of green would be less than number of. I think I will jump on to how to solve other cases later on, but let's just say we have this condition with us. Like let's just say let's solve for this case, and everything else will fall apart. Now what we can do is we can try to first put red, green. Let's say phase one, we first put colors like this. This is my first phase. After some point, what I will have is green would be actually equal to blue. Because here we are only decreasing, in the phase one, we are only decreasing number of green and red colors. So blue is same, and because both of them are more than blue, after some point of time, this value and this value will actually become equal. This is my greedy idea for phase one. Now in the phase two, what I will start doing is, I will put colors like this. Red, green, red, blue. Red, green, red, blue. And keep doing it. Like green and blue, count of green and blue would always be same, and but every time green decreases by -1. Every time you put this way, blue decreases by -1, and R decreases by -2. And keep doing this. This is what I call a phase two. After some point, Either you will run up, now you will end up with two cases. Either you ran out of green and blue. If this is the case, then if value of r is non-zero, just print one more r and you are done. Or what you will end up with is you will have again green is equal to blue. But keep doing this as long as or you will end up with something like this. Like basically keep doing this as long as the count of red is at least two more than the other remaining elements. Like this is the condition when you will stop doing phase two. So the idea is first, because you know that the green is the color you have to use least number of time, you try to create a pattern using only blue and red. At some point of time, like number of times you have to put blue and green would be equal. Here you are trying to save blue for the later as long as you can. Here you are, although you are putting both green and blue, but you are trying to use as many as red you can. At last you will come up with something like this. Either you will run out of green and blue altogether, then you print r whatever value you get, or you will end up with the case where either even red would be equal to all the three colors. Now you have to put all the three colors equal number of times, or you will have to put r one more time than the blue. Like so at this point of time I have to solve for three cases. Either this case or green equal to blue and red is equal to blue plus 1. These are the only two cases that I have to solve now. Like here you will have to try to put some workaround, like how you can print numbers so that you get all the three values equal number of times. This was the hardest part. This is my phase 3. And what I figured out was like basically a string like this can satisfy all of our problem. This is a 9-character string and you use each character 3 times. Now you can keep repeating this string to use as many characters as you want. And you can try to verify it, but yeah, I think I have to figure it out by looking at the problem. But now you can keep repeating this cycle and move on. And the solution for this case was to just put one extra r here. So like, and then keep repeating this 9-character string as many times as you want. And like this was the overall idea. Like it will end up using all the characters only when like number of blue and number of green is less than r. In that case, it will leave out some r. Otherwise, it will put every single character at some point in time. And you can probably try to figure out like the maximum number of r's you can use would be b plus g plus 1 only. Because let's say if you have 3 blue colors and 4 green colors, then you can put blue or green either at even indexes then also you can get maximum 15 length character only. And you put R at, like, what's the maximum number of ways to use R? R, blue, red, green, so on like this. So this was overall idea for this problem, and like this was actually the code I had. First, you try to use as many green and red you want. Keep adding those two characters in the string. Now you will have blue and green equal. Now, as long as the number of times you need R is at least two more times than blue, then print red, blue, red, green, and keep iterating this pattern. So you will every time you will use two red colors and one blue or one green color. And then if you have to place at least one more R, then you can try to place one R, decrease the R, or otherwise I try to flip around some pattern here. And then the overall idea is red, like this is one way to deal with that extra one. Then you can create a new string which is blue, red, green, blue, red. And then you can keep adding these characters as many times as you want and print whatever string you want. I think this was any questions on this so far? What if I just start with green, blue, red till one of them becomes zero? I think you can even try to play around with that as well. Later on, like you are essentially doing what I'm doing phase 1, 2, and 3, you are doing 3, 2, and 1. Like because when one of them will be zero, then you will have to now place the remaining two characters somewhere. And that essentially like actually the last sample is quite a good corner case if you see. Like it reveals if you can handle the last corner case, then I think you might be good. Now let's say I started with assuming that okay, looks like my keyboard is. So I started with assuming that blue is the most used color. B, you have to put the lowest number of time, and red, you have to put the highest number of time. The idea is like if there is any other permutation, you can just swap the colors to get through this combination. So what I did was like let's say I have to put CR character R number of times, CG character Z number of times, and CB character B number of times. Then if like the number of character that I have to put B number of times is more, then I just swap the number of the values there and the character there as well. So instead of explicitly using RGB, what I am saying is that I will put CR character R number of times, CG character G number of times, CB character B number of times, and then I try to swap around the values so that the B is the smallest number and R is the highest number. Kind of like sorting of three numbers where I did it manually rather than using a dot sort, something like that. You can also create a pair of elements and then sort it. So this was the idea for this problem. Any questions so far? So this was problem B. I think E would be the last problem that I will discuss. Later on, I can take some questions from the chat and then I will call it a day. I had some ideas for F, but by the time I went through F, I just had 30 minutes remaining. That was not enough. and then I just decided to move it. Okay, Fenwick tree. I think Fenwick tree is a bit overkill for problem B. Essentially, what you need to do is you need to count the number of characters less than AJ, number of characters more than AJ. Then you can use a lot more stuff. But because n was up to just 5,000, we just did n square solution. Otherwise, you can try to do Fenwick tree, segment tree, etc. But that's strictly not needed here. I think actually I haven't seen the encoder for today. I think I will see it really later on, and I will just once I'm done with this, I can take a look at it. But yeah, I don't know what to say. So problem C says a trivial string problem, and actually it kind of becomes a trivial if you know a lot of string algorithms. Yeah, I am done with discussing C by the way, and if you don't find problems discussion on page, then you can also go to my YouTube channel as well. Like the VOD would be available there. I don't know like how Twitch works, whether a VOD is available or not, but it's always available on YouTube. So you can always go here. So yeah, like I am doing a screencast on both YouTube and Twitch. So problem E says define f of t as maximum number of parts t can be split into such that each part is a non-empty prefix of t. In another word, f of t is the maximum positive integer k that satisfies the following condition. There exists string p1 to pk which are prefixes of t such that t is equal to p1 up to pk. You are given a string s of length and consists of only lowercase English letters. Let x s of x comma y represent the substring of s from x and the yth character inclusive. You need to answer q queries. In the ith query, you are provided li ri. You need to find the answer for substring l2. Let's first keep the problem simple. You are given a string s and you have to find f of s. Then we will see how to solve it for different queries and how to find it for the given sum as well. So let's first try to solve, like let's say we are given a string s and we have to split into maximum number of strings and each string should be prefix. into maximum prefix. Let's say this is what we will figure out. And once we know this, we will jump on to how to solve it for substrings, queries, etc. and everything. Right? So what can we do over here? Let's say this is our string. Let's say this is what we have. Go to the last character and see like what is the longest, or how do we put it? My idea would be like let's go in the increasing order. DPI is number of ways to split first I characters. Maximum when we if we can split. For first I characters. And we maintain this DP. So maximum number of ways to split in this first character is just one. You keep it as it is. First two characters is actually two. You can keep A and A as the two different prefix. For A B would be actually one. You just keep the same string. For ABC, it would actually be one. For the fifth character, now you have two choices. Either you can take the whole string, or you can split this as one and split this as two. So the maximum number of split here would be two. Or in general, like let's say if you are here, then what all possible choices you have? You can either take, like let's say you are here, then what are the different prefixes that end on this string? You can either take this as the last prefix and this dp value plus 1, or you can take this as a prefix and this dp plus 1 or something like that. And overall the idea is when we have to solve for dp1, find all the prefixes, prefix length, yeah actually it's kmp, all the prefix length that actually my whiteboard battery is low at index I. So let's say you got length as L1, L2, L4, like etc. So what you can do is you can take maximum of 1 plus dp I minus L1 I minus L2 And let's say this is the increasing order of length. And I minus L4. These are the four possible choices you have. Looks fine, right? This is how you are going to brute force this problem. How we are going to find L1, L2, L3, L4, let's put it as a black box for now. But once you know all the lengths, then this is how you are going to solve this problem, right? Any questions here so far? So now the nuclear idea is, or one observation that I realized after playing around was, let's say like this string looks like this. This is the longest length, L4, and this is remaining I minus L4 elements. Then my observation was it's always optimal that we will split over this string, always. It's possible that we will do some more splits over here. The key idea I had was, if L4 is the longest length that ends of prefix that ends over here, then in an optimal answer, we will always have one split over here, which would be at 1 minus L4 length. And then there can be few more splits inside this L4 length. So my idea was ki I will say dpi equal to I minus L4 plus maximum ways to split string from I minus L4 plus 1 up to I. Does this make any sense? If what I'm saying is, if I have an index I figure out the longest prefix that can fit over here in the ending. Then what I am saying is, in my optimal answer, I will always have one split over here, and then few more splits inside this L4 string length. So this was the idea, and the key observation here is, because this is equal to the first L4 characters, since it's a prefix, right? So the maximum number of ways I can split this character is same as splitting the first L4 characters. This is equal to maximum number of ways to split first L4 characters. Maximum ways to split 1 to L4. Because since we have said that like the L4 character string is equal to the prefix, then we can say that the element string you have written from I minus L4 plus 1 up to I is same as the string you have from 1 to L4. And because we are solving it in an increasing order, like this formula becomes I minus L4 plus D3 L4. Actually, this problem is not constructive. Okay, problem D. Yeah, I think problem D is a bit constructive. This is problem E. I forgot. And now the idea is like, how do we find L4? Like the longest suffix that's equal to prefix. Like this is actually KMP algorithm. Like KMP algorithm gives you the longest suffix that's also equal to the prefix for each element of the game. So I will probably not go into. I actually have that. I will not go into the nitty gritties of it, but you can read some string algorithms here. KMP is one of them, and then there are more. So Kruth-Morris-Pat algorithm. It says we define pi of s of size s such that pi of I is equal to the length of longest non-trivial suffix of prefix ending at I that coincides with the entire string formally. It says once you run this algorithm, for every substring, starting substring, let's say from 1 to I, it can give you the longest length of prefix that is also the suffix of 1 to I, something like that. And this is exactly equal to the L4 we had in the problem. So you can read it here. I will skip it for this particular stream at least. So this is my solution here. We have a given string t. We first run KMP algorithm to figure out all the longest string lengths here. Like for zero, like for the first character, like there is only one partition. Now you go from all 1 to n. You look at the longest length that is equal to the suffix. If you don't do anything, then you can take whole partition as length 1. Or if there is a non-trivial partition, then you can look at the number of maximum partitions for first j minus l characters, and then the number of partitions for the first l character. Because it's zero based indexing, so I'm using -1 here, and that will give you the maximum partitions. So this is how you solve it for a given string. Now if you look at the query, it says it gives you some L to R character, and you have to find f of value for every particular prefix of this. And because for finding di we also need di I minus l, so this algorithm actually figures it out for all the suffixes of the given string as well. So what you can do is you can first find the string, then you can just take the sum of all the vectors. Overall time complexity here is like the number of characters you have in string t. And now if you want to solve for substring, now if you want to solve for substring, now you can first create a string, and then you solve for the given string using the same algorithm. Overall, this will work because sum of length of all the string is up to 10 to the power 6, and there are only 100 queries. So this would be a 1e8, and that should perfectly fit within the time. Like the only thing you should be careful about is probably try to use the array. Don't create arrays which is of 1e8 length or something. You may run into time limit or something like that. Because like okay, number of test cases is 1e3 or something. I don't know. You may not run it, but I did not risk it. Whatever. Any questions on problem E or any question in general? So like the pretty critical observation was like you will always have a string on the longest prefix that matches the suffix, and solving for the remaining part is just a subproblem which is all 112. Okay, I think I will probably try to look at Adcoder problem D. But yeah, I think 10 minutes for the people in the chat if they want to ask any other questions. I will look at it like I am not committing whether I will solve it or not, but let's see what comes. I think VODs you can find it on my YouTube channel as well. So yeah. Any questions, people in the chat? So assuming like no questions, like okay, so I was inspired from people like Hirayu 80, PC, TP, probability, etc. I think actually Adcoder beginner contest is a nice resource. I haven't solved them from quite a long time, but the way I see is like those contests are really good for beginners. More often than not, they introduces the techniques that are quite well known to some people, and they rarely repeat like. And Codeforces actually tries to enforce other problem, and like at Code beginner contest actually allows people to repeat problems. And yeah, I think you can Look at my feedback on Adcoder beginner contest on the same roadmap to Red channel I have here. I do suggest people. Yeah, like Adcoder will introduce quite a beginner contest will introduce topics that beginners should be aware of. But the problem is, and many a times even Adcoder uses the standard application of that problem, which may not be the case with Codeforces, Codesef, etc. I think I have mentioned doing Adcoder, or probably I did not. Okay, yeah, like the my very first advice is like if you are a beginner, you should participate in Adcoder beginner contest. Don't think much about it. Like among all the latest contests that you will find, ABC is the only contest where you will find standard tricks, etc. So yeah, like if there are no questions, anyone like then I think I will probably go to. I will at least look at today's Adcoder beginner contest probably. Mhm. So ABC is like you are given a sequence A of n positive integer and a positive integer k. You can perform following operation on A any number of times. Add k to A and find minimum possible value of maximum of A minus minimum of A. Oh, it says you can keep adding k to whatever number you want. Either you will increase minimum by k or you will increase the maximum by k. But you have to figure out what is the minimum possible value you can get of this expression. So, like, actually, my very first intuition would be I will take every element mod k. The reason for thinking about that way is like, let's say you can increase 3 each time. One of the element is 1, one of the element is 11. So you first change 1 to 10 first, 1 to 4, 4 to 7, 7 to 10. So you can keep increasing the smallest number such that whenever like the reminder of dividing every element by k is always same and you can just forget about it. So you first take mod of k with everyone, then you look at minimum minus maximum. That's one possible answer you can get. Then what you can do is you can add k to the smallest element. So remove the smallest element, add k to it, and put it back into the elements you have. Now again look at smallest minus maximum, and you keep doing it. And the idea is like when you do it at max n times, every element will become more than k. Then you are again in the same problem, and you can just put a break loop there. So the idea is put all of them elements first. Take everything from the. Why adding k to the smallest value? Because like you have this expression, right, and all the values are between 0 and k. So whenever you add k to something, your maximum is going to increase, and if you don't change anything in the minimum, then your minimum will still remain same. So the idea is if you are adding k on the smallest and second smallest element, then the better way to do is you first add it in the smallest and then you add it into the second smallest. Like let's say I have k equal to 5, or let's say I have k equal to 10, and the values I have are 3, 7, 9. It's possible that the optimal answer is 9, 13, and 17. But you can go to that state by first changing 3 to 13. So you have 7, 9, and 13. and then you change 7 to 17, so you have 9, 13, and 17. So the idea is once you take mod k of some elements, some starting elements you will have to increase by k so that they go to the other half over here. Like, or essentially the way I will put at it is you have a0, a1, a2, everything between 0 and k. Either you take difference of an minus a0, or you can probably look at the pairwise element. Let's say increase. In that case, your maximum would be ai plus k, and minimum would be ai plus 1. So you take difference of these two elements. And you can achieve the same thing by putting all the elements in set. Every time look at the smallest element, remove it, add plus k to it, and keep doing it. That's like solving for I equal to 0, then 1, then 2, then 3, and then so on. So I think this is the idea I have for problem D, and I think the editorial should also be same. Because the idea is like if you say if you are increasing a0, a2, and a3 by k, then a1 would be the minimum element. But if you also do a1 plus k, then the minimum element would be a4, which is still better than a1. Like the idea is I first take mod k, then make it in the sorted element. So overall, this is the idea. And it doesn't really make sense to increase a1. Do not increase a1 and then do a2 plus k, because in that case your answer would simply be a2 plus k minus a1, which is worse because you can just keep an here, which would be less than k. So I think these are the nitty-gritties here. You can probably try to figure out, but yeah, overall this was the idea. And the idea is every time you take smallest, add plus k to it. If you do it more than n times, then you will touch every element over there. So now every element is more than k. So you can just stop there. So I think this is the idea. Yeah, I think this was problem D. Any more questions, anyone? Sir, will you grind for Grandmaster again? Probably not. So yeah, I think this was all we had for today. Thanks everyone for joining in. Yeah, I think I had time in December, January, so I tried to grind it. But yeah. I think the last problem was ABC, but all the other problems were Codeforces round. Like I was done with discussing Codeforces ABCDE, so I ended up discussing one problem from that quarter as well. Yeah, like I am planning to wrap up this stream in next 5 minutes or so. So yeah, actually, okay, I think Codeforces profiles, I think I will probably pick up for the next stream. But yeah, I probably looked at a sneak peek or I think one advice that I would like the problem count here solved is quite sizable. And one thing I have to say is probably not chase for streaks. Probably it looks like you are probably solving 800, 900 problems while trying to chase for the streak. And I think this page is not loading. I was planning to look at what is the rating distribution of the problems you have solved for. So yeah, I think the hypothesis does looks what is the current rating. Okay, so actually, I would strongly suggest be like you try to solve problems which are 1400, 1500 rated. Try to do a virtual contest a lot, and after contest, do look at the editorial, etc. Like, although like you have solved around 1500 problems, but most of the problems are less than 1200 rated also, and that kind of aligns with the rating you have. So, like essentially, try to solve problems which are 1300, 1400 rated in practice. Do virtual contest and definitely do ad coder beginner contest. That's the suggestion I would have. And actually stop chasing for the streak. Like that's one thing I would say. Like streak gives you an impression that you are solving problems, but like streaks don't help anyone. Mine will be, and okay, contest count is around 65. That like actually it looks like you are trying to solve a lot, trying to put a lot, but at least stay a bit calm, and that's where you are. Okay, so around similar profile, and I think like I will probably end up checking the same thing. Like the idea is like if you are chasing for some rating, Then try to solve problems that are 300 more than what your current rating is. And I think my advices would actually be remain same only for everyone. Like they don't really change. So you are around 1500 rating right now. You are at your peak right now, and the number of problems you have solved more than 1500 is around 100. So this does inclines where you are, and you will probably end up plateauing over here unless you are practicing on somewhere else. And you should start practicing 1800, 1900, etc. problems probably 2000, and that's where you are. Yeah, I think the advice will actually be remain same. Like I will just end up looking at different profiles. That's where you are. And you can actually look at USA CEO guide. Even for the, I think Sakura, who I have looked at it, I think you should probably try to solve from here sections. You should start with bronze section over here. I think personally I haven't solved USSEO, but I found it quite curated over here. So you can start solving problems, topic-wise problems from here. And like actually I would say like this bronze section is quite a kind of must-have for people who are starting right now. Okay, Vedant Panda, I think again like the story is same. Just that instead of 1500, I would end up looking at 1600. The advices would still remain same. So none of these, like the advice will definitely not change. It's just that I'm looking at a bot and just saying the same advice. Yeah, I think I will probably look Sahi ready as well. So yeah, I think Vedant Pandey as well. Like the story is still same. Around 1000 problems. Current rating is around 1600. Number of problems tried more than 1600 is around 80. So yeah, like now start solving 1900 2000 problem. That's where you will start seeing more improvement. Otherwise, like I think this would be the current play to you will. I'm not sure if there is a very good bot for ad portal. Okay, if you are 1900 plus or something, I think I would probably first suggest doing CSES problem set and then probably jumping back to USSU. But if you are around 1100, 1200 rated or so, then I think USSEO is kind of a no-brainer for me at least. Are you planning regular stream? At least no much plan. Probably one stream in 15 days, 7 days. If I am with regular, but definitely not the crazy schedule that I used to have earlier. Wait, like my background is actually 7 BHK house. It's just that 3 BHK on the same floor. Don't underestimate a bit. Like the background you see is just one floor of the house, not the full house. Actually, Cango is not even loading for me. Yeah, definitely the background is real. Who keeps fake background? Like I don't know any of the default coordinators. So yeah, like again a new profile. Actually, I would say Suman Roy, like 300 problems, 1200 rating. I think you are actually quite good compared to like the other profiles I have seen. But yeah, the idea is like now start solving 1500, 1600 problems and go for USA silver section there. Like at least you have not plateaued where you are, and I think that's where you are. Is the Discord server active? Like you guys can actually make the Discord server active. That's what I would say. Like just me sending on the message, even if there are a lot, doesn't make sense. So yeah, I think both the profile I looked at, the previous one and the current one, both of them are same. So like the same ideas. Yeah, again, like the solve count is quite sizable. What I'm saying is like the rating is around 1,000 only. And yeah, actually, I would definitely be interested in looking at like the problem solved more than 1,300. So yeah, actually, like the idea is like one common question which I would see from the folks here is like they probably find 1,300, 1,400 problem quite hard. Like again, if I look at it, there are around 1,000 problems solved. But if I look at more than 1,300, it's just 60 problems. So try to solve harder problem. Look at the editorial and everything, and at least participate in the contest, and definitely do AdCoder beginner contest. I think all the advices I have for roadmap to read in 2 minutes actually are for here only. So yeah, I think you were able to solve once 1,300 problems in a contest, but not anymore. So even do virtual contests, etc. And probably try to find like this server that I am maintaining is not a lot active, but you can probably try to join in, discuss it with the folks, and try to solve problems. Like all the people who are asking what to do, I think the best way is like jump into this Discord servers, try to solve your problem, help other folks out, and other folks will actually help you debug your problem, and that's where you will discuss new ideas. Like the idea is like you will find few buddies in the channel. Yeah, definitely bot can suggest problems. You can use actually this git code command to figure out problems for a particular rating, etc. I can revamp this bot a bit, but yeah. I am 1800 rated on lead code, Codeforces or AdCoder first. I think AdCoder would be my first suggestion. So like you can try out to explore the bot commands. It can suggest problem. You can do virtual contests, etc. over it. And if people are interested, I can upgrade it to a better version, which is in few different servers. But yeah, it's just that no one was using this bot server, so there was no incentive for me to improve it. Now we have Claude, etc. as well. Like we can even create one similar bot even for the AdCoder problem or lead code problems. But yeah, so I think this is where we are. If there are no more questions, then I think I will wrap up for today. And thanks everyone for joining in today. And yeah, I think I would probably be a bit more regular. By regular, I mean probably one stream in a week or one stream in 15 days or something. You can always find, you will find Codeforces stream here. I'm not planning to do AdCoder stream anymore. I may do lead code stream if there is an enough interest for it. You prefer Claude or Codex? Actually, I like Claude, and I haven't tried Codex. Like I have tried Cursor and all, but not Codex yet. So thanks everyone for joining in today. This is me signing off for this time. Yeah, like Cango is not okay. Finally, it loaded. If someone is chasing 1600, then okay, I think AdCoder. Then you can probably because AdCoder problems also have a rating. You can use this UI. You can punch in your username here, and you can find rating of all the problems. And this one actually shows how many problem of each section, etc. you have solved. Like, actually, I'm not too familiar with this UI, so might not be able to advise here. But yeah, I think this is what. So thanks everyone for joining in today. This is me signing off for today. And you can find all VOD on my YouTube channel at least. I don't know what's the retention period on Twitch.